All right, well, hello everybody and welcome. I only can give a video that lasts 15 minutes to LinkedIn, so we've got to go fast. This is La Rock Harbor in Isle of Jersey. And we want to look at a valve that I had highlighted earlier. This is the valve. This valve is very important because it allows creation of a hydraulic cylinder based robot, and remembering that this is a hydraulic cylinder. Most people would call this a piston, but actually that's the piston, that's the hydraulic cylinder. I'm showing you this in SketchUp, and over here is the robot. The robot is created using hydraulic cylinders, and we went down here and looked at the hydraulic cylinder that controls dorsiflexion and plantar flexion of the foot. And here's the little valve that I put in there. And again, this valve makes possible robots based on hydraulic cylinders, which are a very better robot if you want to make a humanoid robot. The articulations are better, the stability is better, the strength is better, the way it mimics a human being is better. It's just better. It hasn't been done because no one has quite figured out how to do it yet, but I think I'm getting there. All right, let's look at the valve. What you want to do with this valve is allow you to make the hydraulic cylinder extend and retract itself. And so we'll take a look at this. We'll zoom down and we'll get just this part right here. Okay? And this is retraction of the piston and the connecting rod, and that's extension of the piston and connecting rod. And that's what we're talking about. We've got to be able to get this structure to do that. And the way that hydraulic cylinders work is if you put pressure up here in this chamber, I call this the upper chamber. It's only upper because this hydraulic cylinder is up and down. It's this chamber there's always this chamber and then there's the other chamber. But if you put pressure here and you allow fluid to come out of here, then this piston will go that way and the piston rod will go that way. If you put pressure down here and you put low pressure or suction up here, then the hydraulic cylinder will go the other way. And so let's see how this valve allows that to happen. And again, I shrunk it. I wanted it to be able to be used on the robot without getting in the way of everything. And so it's all pushed together. Now, whenever you're using tubing, you have to have curves that don't crimp off the tubing and pinch it, or you're going to mess up the flow of the material. And so because of that, you get this weird twisted around shape, but that's necessary so that you'll have smooth flow. And so remember that. I'm not doing that just to show off. And what we're going to do is, this is so pushed together that it's hard to see everything, so I'm going to take some parts off. And this is the input system to the valve body. Pressure is red. Pressure comes to the valve body in two places. Blue is low pressure. It's not really suction, it's low pressure. It's return. So from the pump, it goes this way, and then this goes back to the pump. And you'll see that the low pressure goes to the valve body in two places. And this is the valve body, and inside the valve body is the stem of the valve. And the stem of the valve has holes, passageways in it. And when the hole, the passageway, is not lined up with these ports, then fluid that's trying to come in here won't go anywhere. Now remember, this has all been altered in its transparency so you can see through it, so you can see what's going on. The truth is it would actually be metal and it wouldn't be transparent. But you can see that this one's lined up. So if some kind of a fluid is coming into this port or coming out of this port, you could have a fluid that will go across here. And so that's important. Now, let's look at what the the connections are. And again, I've taken some stuff off of the hydraulic cylinder, and this is the access to the upper chamber, and you'll see that the upper chamber of the hydraulic cylinder is connected to the body of the valve in two places, right here and right there. And you can see that the lower chamber of the hydraulic cylinder is connected to the valve in two places. One place is right there and the other place is right there. And what happens is the position of this valve determines what's going to happen. I do have this structure right in here, right here. This is a bypass valve. What this bypass valve does, it's a solenoid activated valve. If you open it, that takes one chamber of the hydraulic cylinder and connects it to the other chamber of the hydraulic cylinder. So we're not going to get to that yet. Now, this, you can turn the stem. That's all I'm trying to show. The drawing program doesn't want to mess with it. I don't know why, but you can turn the stem. The stem turns, the body of the valve doesn't turn. So now we can go over to this particular version of the valve where I took the stem. You can see here, I put a little marker on here, and we took the stem and we pointed it to position number 1. And there's a little motor and gear system here that's turning that stem, but I made it transparent so you can see through it, and it's pointing to position number 1. And when it's pointed to position number 1, the pressure comes in, it goes here, that's connected, so it goes through there, it goes also up here, but this is crosswise, so nothing flows here. And when the pressure goes through here, it goes into here, it comes into there, this goes up this way, but this is connected to a crosswise connector, so this goes nowhere, but this is connected, and the pressure goes into the lower chamber of the hydraulic cylinder. So when the stem of the valve is in position 1, the pressure is connected to the lower chamber, and by the same type of routing system, the low pressure return is connected to the upper chamber. And so since the pressure is here and the low pressure is there, the hydraulic cylinder moves that way. And in a similar manner, if you rotate the stem from the number 1 position over to the number 2 position, everything is flipped around, and the pressure that was going through here, that's all turned off, but now the pressure can go through there, and it goes right up into here to the upper chamber, and the suction that was going to here can't, but it can go through this one, and the suction is then routed down into the lower chamber. And so when you take the valve and put it in the number 2 position, you wind up with the pressure above and the low pressure below, and the hydraulic cylinder goes in the other direction. So all you have to do to change the movement of this hydraulic cylinder is just rotate this stem. And what I wanted to show, there's a third position here, the off position. When it's in the off position, none of these passageways are lined up with anything. And so everything is all completely blocked off. And I made this sort of a darker color, a gray, like nothing's going on. So this hydraulic cylinder is locked up and won't allow any movement. Finally, I did put in here this solenoid connected on-off. If you open this up, so you put this stem in the off position so that the pressure and return are not affecting the hydraulic cylinder, and then you open up this valve right here, and that means that the fluid here is connected to there. And so whatever forces you put on this piston rod, the hydraulic cylinder will agree with you. It doesn't care. It's not under the control of the pressure and suction system. It's under the control of whatever forces are on the hydraulic cylinder. This will allow that easy fluid motion of humans, because you can lift your leg up, pull it backwards, lean forward. As you're walking forward, you can set the pistons that need to be set into this free flowing condition, and the leg that's behind will just swing forward under the influence of gravity, and you don't have to pressure it forward. You don't have to drive it forward. You don't have to use energy to make it come forward. You can use a gravity system, which is where that gait of human beings comes from. And at any point, if you need to add some force to it to make up for the fact that gravity wasn't perfect, you just shut this bypass valve and turn the stem to wherever you want it. And the last thing I wanted to show you was you can take this arrangement of tubes. These tubes are 1/8 inch diameter. And here's how this works. Human muscle moves at 15 centimeters per second. That's as fast as it goes. So you don't have to have this move any faster than that. And the flow of fluid in this tubing needs to be at a rate of flow, or a velocity of flow, less than 15 feet per second. So if this is at 15 feet per second, and this is moving at 15 centimeters per second, it allows you to calculate what is the smallest diameter you can have here. And that this hydraulic cylinder is, the size here is times 100, so it'll draw better. But it's 3 inches long and it's at about 2 inches in diameter. And so what that means is these can be 1/8 inch. And if you had a much smaller cylinder, hydraulic cylinder, you could make a smaller valve, except you can't bend these tubes around much smaller than that. But you can take and drill holes in a solid piece of metal and then weld little plugs in place. So you can make something like this that's only a 1/2 inch long. You can make a valve that works just like this valve, except this whole entire valve is the size of a raisin. And I'll get into how to do it, but I can't do that in 15 minutes. And the last thing I wanted to discuss was the turn. I use this. You can buy these from Alibaba for $7 each. But this is just a motor and a gear train. But there's another way to do this. Okay, and there's a lot of companies like this. This is a brushless DC motor. And you can get whatever size of this motor you want. And the motors can be obtained with a gear head that goes with them. And this is just one company, but there's lots of them. And here is their catalog showing gear heads, and it shows what torque the gearhead can create, what motor goes with it. And this combination of a gearhead and a motor, this motor is digitally controlled by a digital encoding system that this company also sells for their motor. And we can go back to this. If you go out to the internet and they asked athletes to give maximum contraction of their muscle as fast as they could, and it takes 150 milliseconds, which means that if you want this system to duplicate a human muscle, it needs to be able to go from the off position to the number 1 position in 150 milliseconds. But that or from off to number 2 in 150 milliseconds. But that becomes an RPM rate, and you can take this RPM rate with that digitally controlled motor and that digitally controlled gearbox and get this turning at that RPM rate. It doesn't have to turn any faster than that. All right, so that's all I can do in 15 minutes. I'll just tell you, I just simply don't like having to hurry through. I've left out so much. But it does allow you to create a piston hydraulic cylinder based robot. And I do have one with arms on it. I created a shoulder and an arm. And I'll make a YouTube where I go over everything much more slowly to show really how this is done. You do have to get the torque requirement for that stem, but that can be done. And we'll continue to show you. And the little tiny valve is going to be the valve that runs the pistons that run the intrinsic muscles of the robot hand. That's another lecture I'll make for you. Anyway, thanks everybody.